Okay, so okay, y equals a times b to the x, like y equals a times 2 to the x, or y equals a times e to the x, or y equals a times 1.04 to the x, which is something you would use like for a 4% interest. Okay? Now, got a word for B that helps you understand what this means. It's your growth factor. Okay? Now I'm going to come back to an interest problem to indicate what show you what this means. Interest at rate 4%. Compounded annually for reasons we've been over, gives you a principal function, which is the original principal times 1 plus 0.04 raised to the t. Should be familiar to you. If it's not, make sure you go back and make it familiar. Okay? And of course, this equals P naught, your initial investment, multiplied by 1.04 to the t. So B equals 1.04, because B in your general explanation function, your general exponential function is a thing that's raised to the power, right? Thing that's raised to the x power or the t power in this case. Okay? And maybe, since I'm using t here, I'll change this one to t because it's sloppy. Okay? So B equals 1.04. This is your growth rate. This is your interest rate. Okay? Sorry, this is your growth factor. .04 is your growth rate. Okay? And another thing is, because we're talking about factors and rates, and when we talk about rates, you easily confuse that with rate of change. Your growth rate is not a rate of change. Bad notation, but you get the idea. What we just talked about, right? So don't confuse growth rate with a rate of change. Different words. Which is why I tell you it's important to use all the words. Okay? Rate of change of this with respect to that. That's what we mean by rate of change. 0.04, 4% is not a rate of change, it's a growth rate. And that's confusing because it uses the word rate, which is why you got to use the right words when you're thinking about it, and especially when you're first working with it. Okay? Now, this is important terminology, but you know, it is pretty simple. bigger your growth rate, the bigger the number you're raising to t, so the faster your thing's going to grow, and the greater your growth rate for a given t. Okay, or the greater your rate of change for a given t. Okay, well, when you really do the mathematics, you really don't want to be using your growth rate as your base. But your growth rate is extremely important for understanding your function. Okay? So we have, when you do mathematics at the level of calculus, you don't want to be doing calculus on this function. You want to be doing calculus you want the form AE to the KX. Now, if it's just AE to the X, then that would mean the growth rate has to be about 172%. So you put a K in front of it, which allows you to make your growth rate faster, or greater, or less, okay? And it's really easy to do this because you know how to do this, and I can explain it or demonstrate it in the 4 minutes we have left. Because you'll recognize it very easily if you understand the concept behind this. Okay? So if we know B, our growth factor, we need to find K. Such that what? Well, such that this model is the same as this model. And I'm using t instead of x. I keep writing x out of habit. So for all t values, we want this to equal this, because if this equals this, then this model is the same as this model. And if we know k, we could find b, and if we know b, we could find k, because what happens? What do you do with this equation if you want to find k? T is a variable, it's going to stay variable, right? So either we know k or we know b. How are they related? Well, let's just solve for k. How do you solve this equation for k? What's your first step? First thing when you look at that equation you want to do other than run the other way. Pretty obvious first step. Give it a stab.
Get rid of a.
Do you mean divide both sides by a?
No, I just omit it.
No, you can't just get rid of it. You got to do it mathematically. You know what to do. Okay, divide by a. Well, then you get e to the kt equals b to the t. Now what do you do? Well, now it gets maybe a little confusing because you've got to use the laws of exponents, and now it's not as obvious. Okay? But e to the kt means what? One way to rewrite e to the kt is e to the k raised to the t power. And that should equal b raised to the t power, right? E to the kt, by the laws of exponents, is the same as e to the k raised to the t. And as I've been nagging you from the beginning of the semester, you've got to really know the laws of exponents and the rules for logarithms backwards and forwards. Okay? You're doing pretty good with the laws of exponents, but not sure everybody's at 100% with that, so make sure you are when you get to the final. Okay, well, if e to the k raised to the t equals b raised to the t, what can you say?
E to the k equals b.
So e to the k has to equal t. And to solve e to the k equals b, natural log is the inverse function. Okay? So e to the t is your natural log, or your natural exponential function, and its inverse, natural log of t, is the natural log function, right? Because I just said the inverse is the natural log of t, which is the natural log function. It's almost a tautology, okay? Understand what I'm saying? So this, if you understand this step, then understand, well, if something raised to the t equals something else raised to the t, that's something that better equal that something else. You get this immediately and then this instantly. Because y'all are pretty good at changing between exponential and logarithmic form. Okay, I think everybody's doing quite well with that. Make sure you're really on top of it. Okay, fair enough? Okay, good.